Hi, my name is Elijah Barnabas, and today I'm going to present about the proposed defense of my project. I'm from Faculty of Engineering Technology, and this is my title: A Comparative Study of NAK80 Steel and Beryllium Copper Mold for Injection Molding of Polycarbonate Materials. My supervisor IRTS Dr. Asnizam bin Ahmad, and this presentation contains three chapters, which is Chapter 1 Introduction, Chapter 2 Literature review, and Chapter 3 Methodology. Okay, the first slide is about background study. Uh, Firstly, plastic injection molding is a manufacturing process for producing parts by injection molten material into a mold. The plastic injection molding process is widely used in a variety of industries. It is most frequently utilized in a mass manufacturing procedures when the identical component is produced again hundred or even million more times. The process begins with the creation of a mold, which is typically made from steel, copper, or aluminum. The mold is then heated via hot fluid flowing through parts in the mold to a specific temperature and injected with molten plastic material. The plastic is forced into the mold cavity by ram or screw type plunger. Finally, the mold is then cooled and the part is ejected. The continuation of background study. Plastic injection molding resin such as polycarbonate have some benefits. For an example, it is a durable material, has external thermal stability and resistant to chemical and UV radiation. Even though plastic injection molding appears simple, its variable have a considerable impact on the final product's quality. For instance, several issues might arise when the parameters for plastic injection molding are set incorrectly. This includes poor part quality, increased cycle times, and increased scrap rates. Poor part quality can be caused by incorrect temperature setting, which can lead to warping or shrinkage of the parts. Incorrect injection speed or pressure setting can lead to incomplete filling of the mold, resulting in weak parts. In addition, incorrect back pressure setting can cause poor part ejections, leading to increased cycle time and scrap rates. And this slide is about problem statement. Due to many aspects including operator training, machine capability, material selection, part design, mold design, cavity structure, and cooling time, different mold materials have different cycle periods when used in injection molding. The cycle time of injection molding when using NAK80 steel and beryllium copper molds for polycarbonate material is an important consideration for manufacturers. The pressure difference between the nozzle and mold cavity may disrupt the quality of the product. Melting temperature influences the plastic viscosity or resistance to flow and is critical in obtaining optimal part dimensional stability. The objective of this project. There are two objectives for this project, which is to investigate the effect of process parameters on the cycle time of injection molded part produced using steel and beryllium copper molds. Secondly, to compare part shrinkage and weight of the molded parts produced using steel and beryllium copper molds for polycarbonate injection molding. The scope of the project. Firstly, we focus on thermoplastic injection molding for plastic industries. Secondly, the molded part sample is a cup and the mold insert material are beryllium copper and NAK80 steel that assembled in the existing injection molding mold at Modern Manufacturing Technology Workshop at UTHM campus. The material for polymer resin is polycarbonate ST Macrolon 2805 Covestro. The study involved experiment process to compare two different mold materials. The selected injection molding processing parameters are melting temperature and injection pressure. The Fanuc troubleshot S50IA injection molding machine is used to conduct this experiment. This injection molding machine is in modern manufacturing technology workshop at UTHM campus Papu. The molded part shrinkage of the sample cup is measured using the CMM, which is coordinate measuring machine at metrology lab. Significance of study. The process effectiveness and quality are significantly impacted by the material used for the mold. To further understand how these mold materials function in this procedure, a comparison of NiK-80 steel and beryllium copper molds for injection molding using polycarbonate material is conducted. This injection molding process are used all around the world in injection mold components that are subsequently used to create plastic products using different mold in the plastic industry. Moving on to the next chapter, which is literature review. In this literature review, I'm going to talk about the injection molding machine. The plastic injection molding completely functional piece involves melting plastic resin and injecting it into a pre-hardened mold, which is a common manufacturing procedure for producing components of various sizes and shape made of plastic. Uh, this is the picture of the injection molding machine, which is contain three units, which is clamping unit, injection unit, and mold assembly. This slide is about injection molding steps. The first step is plastic granules fed via hopper, which is a funnel, into barrel and heated to a molten state. Secondly, the heated plastic fill the barrels and a motorized screw pushes the molten plastic into the mold. Thirdly, the screw injects molten plastic at pressure into mold cavity via gates and hot runners. Then the final step is the plastic product is allowed to cool and solidify before being ejected from the opened mold. The main components of injection molding mold. There are eight types of main components in injection molding mold. Uh, the first is clamp plate, and the second is sprue bushing. The third one is feed system. Fourth is cavity pathway, and the fifth is cooling system, and sixth is guide pillars, ejector system, and the last is ejector plate system. Material of the mold. A crucial step in the process is the creation of the injection mold, which is created using CAD drawing, produced and split into two halves. The function of and requirements of the produced product part are taken into consideration while selecting the raw materials for injection molding. Molds are often made of steel, aluminum, and copper by the manufacturers. These two pictures are shown. The first one is beryllium copper and the second one is NiK-80 steel. The reason for injection molding. Polycarbonate is one of the most popular engineering thermoplastic because of its transparency, outstanding hardness, thermal stability, and extremely good dimensional stability. It is used in electrical components, safety helmets, riot shield, infant food bottles, and headlamps lenses. This picture shows the PC chemical structure. There are four types of injection molding process parameter. Firstly, injection pressure. The force used to propel the molten plastic material through the screw and into the mold cavity is known as injection pressure. Secondly, the melt temperature. Melt temperature describes the polymer actual temperature as it leaves the nozzle and enters the mold. Thirdly, the cooling time. Cooling time represents the interval of time between the injection of plastic fluid into the mold and the removal of the component. And lastly, the filling time. It speaks how long it takes from the beginning of the injection molding to the point at which it leaves the mold chamber is filled. The quality factors of the molded part. Dimensional accuracy of the molded part. The accuracy requirements for dimensional precision from form quality and physical qualities of the finished product are frequently determined by the accuracy of the injection molding. Wear and tear of for molded part. The parts of plastic injection mold wear out due to contact or friction between parts, and in addition due to glass fibers contained in the plastic resin. Surface finish. Surface finishing enhances the product's appearance and feel, and a good surface finish raises the product's perceived worth and quality. Mechanical properties for molded part. Mechanical characteristics such as hardness, stiffness, and tensile strength vary among different materials. And this slide is about project process flowchart, which is chapter 3. Uh, for a start, the mold material selection. There is two materials for the mold, which is beryllium copper and NaK80 steel. Secondly, the polymer material selection. The selected polymer resin is polycarbonate for the first objective, which is analyzing molding cycle time. The chosen process parameter are injection pressure and melting temperature. Then the sample cups are produced using the injection molding machine. For the objective 2, the demonstration of injection molding part shrinkage and weight is evaluated by using the produced sample cup. These cups are evaluated using CMM, which is coordinate measuring machine, for shrinkage level and weighing scale for the weight check. After that, the data must be collected and converted into graphs, and finally use the data and the result to do conclusion. In this slide, it shows the design of the sample cup. This slide is about the list of process parameter setting. In this table, there is 9 levels of process parameter setting for both the injection pressure and melting temperature. The fifth level is default setting for both parameters. The experiment is carried out based on the defaulted parameter set with 4 selected high melting point and 4 high injection pressure levels above the default melting temperature and injection pressure, and 4 selected low melting point and 4 low pressure level below the default melting temperature and injection pressure. After conducting the process parameter experiment, the second step is the quality check of the sample cup. The quality check is it's like a uh, analyzing the sample cup weight using the weighing scale using the same produced sample cups, and secondly evaluating the sample cups shrinkage level using CMM, which is coordinate measuring machine, by using the same produced sample cup. I sincerely appreciate your attention. Thank you.